evaluate the triple integral over the domain E x dv, where E is the solid bounded by x equals 8y squared plus 8z squared and x equals 8. Now, if you look at carefully the graph or the surface x equals 8y squared plus 8z squared, which is a circular paraboloid going in the x direction. So I'll show you the picture, how we draw it. So it's going in the x direction. There's a circular paraboloid. This is 8 units for x, as you see there. And this surface x equals 8y squared plus 8z squared. All right. So at the intersection, what happens? X equals 8. So we write 8 equals 8y squared plus 8z squared, is right? So after simplification, we see now y squared plus z squared equals 1, which is a unit circle, right? Now let us draw that one too for yz plane. We have a circle like this. Y limits going from -1 to +1, and z limit goes actually on the boundary. If you solve for z, you get z will be equals plus or minus square root of 1 minus y squared. Is that right? So we have all the limits now in our hand. So let me write all the limits. We see our x, the highest you can have for x is 8, and the lower boundary is 8y squared plus 8z squared. That's x limit. The y limit is between -1 to +1, as you see in the circle, and your z limit goes from negative square root of 1 minus y squared to square root of 1 minus y squared. Is that right? So then this integral now we can write as this. First, I'm taking y limit goes from -1 to +1. Then z limit goes from negative square root of 1 minus y squared to square root of 1 minus y squared. Then I'm going for x limit, which is 8y squared, 8z squared to 8, and I have my function x already there, and follow the order of the differentials. So first I have x, then I have z, and then I have y. Okay, so let us clean the screen and start working on integration. So first we'll be taking integration with respect to x. That gives me 1/2 x squared, and limit is 8y squared, 8z squared to 8, and then we have dz dy. All right. So when you plug the limit over there, you see -1 to +1. I just carry whatever we have here, square root of 1 minus y squared. You can pull your half all the way to the left side. The limit for x, the boundaries you have there, plug it. 8 squared minus 8y squared, 8z squared squared. So this is the setup now here. If you look at carefully, we are able to use polar coordinate in this case. So let us look at the yz domain again, because x portion is over. -1 to +1, and we have a complete circle rotation here. So you can see theta is between 0 to 2 pi, and r is going from 0 to 1. All right, so we can write the polar form. So as you see, now we can go, theta is from 0 to 2 pi, and r goes from 0 to 1. And this function now can be written as 64 minus, if we factor out 8 in here and then square it, that will be 64, and then y squared plus z squared will give you r squared, and then square outside will make it 4, and then dz dy will be replaced by r dr d theta. Now with the separation of integrals, we can bring theta on this side. We get 1/2 times 2 pi. Now the integral of this one You can distribute r in here. You get 64r. You can factor out also 64. Let me do some simplification first. As you see, 0 to 1, 64r minus 64r to the 5 dr. And then you can take also 64 outside. So finally we get pi here, and the integral of that one, I'm taking 64 outside. So then you get r squared over 2 minus r to the 6 over 6, and the limit is 0 to 1. So you get 64 pi, and you get 1/2 minus 1/6. So 1/2 minus 1/6 will give you 64 pi, and then 2 over 6. So that means 1/3. So you get 64 pi over 3, and we are done. Thanks.